Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 139, I chat with Garth Powell of Furman Sound and Marshall Currier of Panamax about AC power and its effect on the performance of your home theater system. So stay tuned.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded December 3rd, 2012. Episode 139, Performance Power. This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson here, the Home Theater Geek. On this week's episode, I have two guest geeks, and they are in fact in the TWiT Brickhouse studio. They happen to work in Petaluma, so really happy to have them in the studio. We have Garth Powell, who is the senior product developer and engineer at Furman Sound. Hey, Garth, welcome to the studio and to the show.
Thank you. Thank you very much, Scott.
And also Marshall Currier, a national trainer for Panamax. Both of these companies are AC power management companies. They make AC power products, and that's what we're going to be talking about today. Marshall, thanks so much for being here.
Hey, Scott, thanks for asking us over.
You bet. Well, how nice that you live or work at least a couple minutes away from the TWiT studio and can go and see the studio itself. Pretty nice, huh?
Yes.
It's really beautiful. Yeah.
Yeah. I was admiring the antiques, the old Commodore, and the restoration hardware elm tables.
Yes.
My new fiancé has been like eyeing one of those and things like that. So it's nice to see how it holds up.
Very good. Very good. Well, perhaps you can talk to people there about where they got them, and maybe you can grab one yourself.
Right.
Anyway, we are here today to talk about AC power. And as we do on every episode, I want to invite those of you who are watching live at live.twit.tv or logged into the chat room at irc.twit.tv to post questions for Garth and Marshall, and I'll be happy to pass along as many as I can. So the first question I want to ask is a bit of just a procedural question here. Panamax and Furman are now related in some way. They used to be separate companies, and now they're together, but they have separate websites. What's the relationship?
Do you want to grab that, or should I?
I'll take it. In 2006, Panamax actually acquired Furman Sound. What was funny was we worked across the street from each other for years.
Yeah, over 30 years.
And so Panamax acquired Furman Sound. There wasn't really a lot of market crossover. Interestingly, there was enough differentiation that we thought the lines could actually cohabitate within the marketplace very simply together. And after the acquisition, we actually leveraged a lot of the engineering abilities of both brands, built some really awesome products, and we've got actually a couple discrete lines that are still Panamax and Furman branded today. So they're still completely independent brands from the consumer standpoint.
Yeah, and what I liked about it too is so often because both companies are part of a larger corporation called Nortec. And what happens so frequently, you see with Harman International, D&M, a lot of different companies in our particular spectrum of the marketplace, particularly for home theater. Sometimes they come in, and with big corporations, it's always the same story. Oh, we just want to help you grow. We're here to support you. We're just going to, give you a big hug and leave you alone to do your business. And it's not the case. Basically, you're just counting the minutes before they go in and start messing with things. And the truth of the matter is that although our financial people and all of our accountants would certainly argue that they have far more work and accountability to the corporate overlords as they were, good, benevolent though they may be. Certainly in terms of design work, in terms of engineering, things like that, we have been given a lot of autonomy. We have been given the ability to keep what was great about the lines there. And we work with each other to build on those strengths and work with each other, and yet at the same time keep those differences in the brands very distinct and not just trying to blend everything into one. If I use a car analogy, it's not, what we really wanted to avoid was the idea of the Ford Mercury paradigm where the difference is a leather interior and a hood ornament.
So what differentiates then the Panamax products from the Furman products? Is one for like more commercial use and the other for consumer, or how are they differentiated?
I can take a little bit of this, and I think Marshall will probably have his own perspective as well. With Furman, for one thing, traditionally, we came from professional audio, video, and broadcast, and also music industry. And that was really where we cut our teeth. Jim Furman, the founder of our company, was essentially an engineer for the Grateful Dead, as many professional audio people were in the Bay Area. And people in this generation don't really realize this, because to them it's sort of like, a bunch of hippies that got very, 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 stoned on psychedelics and listened to Jerry Garcia noodle on in Phrygian mode for 30 minutes. But the reality is I'm a musician, so I love them. But the fact of the matter is that band, unlike many other bands, with the exception of maybe Frank Zappa in Southern California, some of the best audio engineers in the industry came out of that background, because anybody that was ever attached to them, that group was willing to funnel insane amounts of their money and invest a lot into the future of professional audio. If an engineer wanted to try a grand experiment that was going to cost millions, they were like, yeah, man, let's try it. Where anybody else would have been like, you're kidding, we just rent something. So a lot of good technology came out of that period, particularly in the 70s, and that was, fortunately, kind of the genesis for us. Somewhere along about 10 or 12 years ago, 16 years ago, I started with Furman, and I really kind of came more from an audiophile and a home theater and a broadcast video background, and sort of pushed and snuck and sort of eventually found a way for myself by essentially creating a line. And at that point, we were very, very small. There was no point trying to be like our very respected partners across the street, Panamax, because they were already doing soup to nuts line very, very well, particularly at the more affordable range. But when I looked at the higher end range and highly technological, and particularly for performance, like getting the best out of audio and video, like cost no object, they weren't doing that quite so much, and the people that were doing it, I didn't think were very science-based. So we decided, that's going to be our little niche, and those were a lot of the things that I designed along with the rest of our engineering team. So when we got together with, later on with Panamax, it was a situation where, because prior to that acquisition, we'd been forced to create a full line. There were a few things in the middle that needed to be weeded out because there was some crossover. But for the most part, the Pro division didn't cross over at all. That was just, perfectly, legitimate extra business for Panamax and for Nortec. And for the middle part, it was just a question of realizing, okay, we've got a quality brand, from this price point and up to this price point, and for control and protection, and then for high performance, there's the Furman line. And we also had to really, if I use another car analogy, which I shamelessly do, there was a tendency at first for our salespeople to oversimplify and kind of, because it's so easy to kind of say, oh, well, more expensive equals better, which is not always the case in most things. So you can throw a lot of money into design and do a poor job, and vice versa. So there was a kind of tendency at first. It was like, oh, well, it's sort of like Furman is Lexus, and Panamax is kind of more like Toyota, but it's not really true. The way I if I'm going to use a car analogy, the way I like to put it is that Panamax is Range Rover and Furman is Porsche. It's application. What are you trying to do? Are you trying to race on-road or off-road? They're both great products with incredible technology. And Marshall, I'm sure, has a perspective on this.
Yeah, I was going to say, Marshall, what have you got to add to that?
So the interesting thing about that just finishing piece is exactly it. It really comes down to application. Because if you look at the key technologies that Furman utilizes, the key technologies that Panamax focuses on, whether it's IP control, power sequencing, Furman leverages power factor, balanced power, discrete symmetrical balanced power. There are a variety of technologies that actually really break the brands down. So it really depends on what you want to do. If the focus is purely performance, then Furman is the way to go. If the focus is a combination of protection and performance, and it's more of a price-conscious decision, then Panamax is the way to go.
And also control, because that's one of the big advantages of Panamex, and has been for some time now. But both brands have some of that, but there's far more depth in the Panamex line where that's concerned. Control. And really, even for premium home theater systems anymore, more and more with the systems I'm designing for our high-end clients, particularly for six-figure systems, I'm essentially using both brands because at this point I have no choice. I'm going to have IP control for my servers, for my switchers, for a lot of my distributed audio video, because I want to be able to monitor it. I want to be able to shut it down. I want to be able to conserve energy. For my amplifiers inside the theater, where I want dynamic range and I don't want them to current compress, when I've got the very, very best projectors, when I have a large plasma screen that's in my main theater, where I really care about the resolution and squeezing every bit of it I possibly can out of it. My preamp processors, a universal player, a Blu-ray player, something like that. I'm definitely going to want the Furman technology if I possibly can, if I got the budget. And we also have battery backup, because you're going to have areas where you're going to have blackouts, and certainly a cable or satellite box, you have absolutely no choice. A controller main system, you have no choice. So it's a modular approach. It's never one size fits all. Broadcast facilities and things like that, because of the complexity and the fact that you have multiple zones, always are kind of like looking for a one hit. Can we put something in the electrical room? And there's nothing wrong with doing that as a start, but the problem is, in a perfect world, I would literally have power management for every single component. That's not practical, but the closer I can get to that, the better off I am, because there's so much noise that's going to be created inside the environment, component to component. They're all backwashing back through their cords into the power supplies. You've got power coming through the best power supplies, linear switchers, through current noise. And also, if you've got a grounded power cord, it's coming through ground, because ground is truly only earth at one point in the earth. Every place else, it's above that, and it's transmitting noise, particularly in the digital age.
Well, you've brought up so many things to follow up on. Let me try and get to a couple of them here. Grounding, for example. Yeah, he's an engineer. Now, we got to remember, you're an engineer. Now, this is a show called Home Theater Geeks, so we can get geeky, and that's totally fine. But do try to remember that not everybody listening might have quite the same level of background knowledge that you do. So I might, at one point or another, ask you to explain something.
That's fine. No, please.
For example, grounding. You said that there's only one true point that's going into ground, and I understand that. It's true in homes, it's true in recording studios and TV stations and so on. How do you make sure that all the pieces of equipment are grounded to the same point as much as possible? Because when they're not, of course, we end up with what's called ground loop, which manifests itself as a hum in the audio system and as moving bars in video displays sometimes. How can we make sure that we've got everything grounded to the same point? And let's focus on home theater here if we can, because after all, the show is Home Theater Geeks.
Sure. Well, actually, and as much as you just asked me to do that, I'm going to cheat and go a little bit into broadcast just briefly, because if we do this the classic way, the way it may be done here, I haven't taken a look at your panels, but certainly the way I was taught as an apprentice in my teenage years to a couple of broadcast engineers. In that particular world, everything in your racks is floating. All of your three-prong AC cords, all the ground points are chopped right off, and then instead
pardon me for interrupting, but by floating you mean the grounds are not connected to anything.
Correct. But then to be legal and safe again, because you do want that redundancy ground also as an RF drain, you go right to the chassis, and then you have an insulated large bus wire, and all of those particular components, every last one of them, is going to go to one ground post via ring lugs in what looks like a star. This is thus called star ground. And then from that particular, like a single point ground, you have a massive piece of copper wire. Could be silver, could be anything you want it to be, really. And that's going to go out to your main technical ground rod. And the idea here is that it doesn't matter if that component is a mile away or 1 inch away. If they're all coming to a central point, you're not going to have any possibility of differences or differentials in neutral to ground like voltage. Because of this, you can't possibly have that hum, 60 cycles and the harmonics beyond, or those rolling bars going up your screen. Now, problem with that is that's completely impractical in a home theater, and no one's going to be able to pull this off. Not to mention the fact that, besides the fact that usually you're not going to be able to float everything in 2 or 3, 4 or 5 racks in some very big ambitious systems. In addition to this, you've also got the problem that you're mixing balanced, like audio lines with unbalanced. That's a grounding issue. Then you've got cable and satellite boxes that have been grounded to the nearest drain pipe because those people want to be legal, but they're not putting it at the same place. If you're a CEDIA-trained installer, you know to try to bring everything, out to all of your branch circuits on the same phase. Because if you go back to your electrical panel and you measure with a simple voltmeter on a split load in a home, like line 1 to neutral versus line 2 to neutral, you can typically see, because of appliance differences on one line versus the other, as much as a 5 or 7 volt difference. Well, you only need a fraction of a volt to develop a ground loop. So in a situation like that, you're in trouble. So definitely having everything on the same phase will help. And if it's a standard dealer's facility or something like that, or a professional building, then it's going to be 3-phase. And then you've got 3 opportunities to mess everything up. So you definitely want all your audio and video to be on the same phase. And that's the ideal. But all of this gets destroyed by the fact that we live in the real world, and frequently that doesn't happen. So then you're down to isolation transformers for audio and video. And there's companies like Cinemag and Jensen that deal with these, particularly for cable and satellite. Video humbuckers and video isolation transformers, very, very common. You also have a situation where our, like we, along with other companies, have isolation transformers, where sometimes that'll be necessary for some of your line level pieces. When a project tends to be on a very, very tight budget, and the contractor is in a big hurry, and they're trying to diagnose things, they can bring cheater plugs where you're essentially just floating the 3-prong AC cord to kind of like determine, okay, well, if I try this to this cord, does my bar go away? If I try it to the second one, does the bar go away? If I put it on 1 and 3, does the bar go away? And that helps a lot to kind of like determine what the problem is. You don't want to leave them there. That's illegal and unsafe. But it can help you in terms of your diagnostics. Also, carrying a large, 50-foot or bigger extension cord with you, because often in a theater and in a home with distributed audio and video, you can have multiple flat screens around the home, but they're all sharing signal back to your switcher. And then you've also got, like in your theater, remote-powered subwoofers. You've got the up in the ceiling, you've got your projector. Everything's at a different ground potential, because really everything needs to come to one ground bus, but that's almost impossible to do. And by the way, if you're running more than 20 amps, or your theater is big enough to be, requiring more current capacity than that, then by definition, there's no way you could ever possibly create a true star ground unless you did it the broadcast way, where you're just chopping everything off, basically running buses to the components, doing a lot of work that no one can ever do. Plus, in the broadcast scenario, everybody understands that is the domain of the head of engineering, and no one will ever touch anything, or your job and your life is going to be threatened. Whereas in a home, that just won't happen. That's not practical.
Well, on the other hand, though, even in a home, if you've got a home theater that's going to draw more than 20 amps, aren't you going to hire a professional to do the electrical correctly? I mean, if you're smart.
Electricians, God bless them, unless it's an electrician that comes from broadcast and knows what a star ground is and knows what dedicated runs really are, not just a dedicated line, but also dedicated neutral and ground. And no, I don't mean daisy chain to the next 5 adjacent outlets. I take that call twice a week for the last decade. The amount of electricians that do not understand this, and it's not their fault. The fact of the matter is that the National Electrical Code was set up for fire. It was set up for fire prevention and to prevent electrical shock. It has nothing to do with performance. It has nothing to do with eliminating ground loops. And most electricians understand nothing about that. It's not how they were trained.
Scott, your comment regarding under 20 amps, assuming that is the, minimum amount of current a whole system would draw, the simplest way to do that for a home theater environment would actually be to make sure everything is wired to the same power conditioner or same power management product to the best of your ability. So as long as you get away from plugging in the subwoofer to the back of the room, or wiring the projector up to an outlet that's not associated with that same power conditioner. Those are big no-nos. As long as we're avoiding that, you don't have to get into kind of rewiring your own, electrical system in your living room.
Right.
Yeah, and like many other manufacturers, one of the things that our company does have is the ability to, in a code-compliant way, essentially running extension cords through the wall. It's called dead-end wiring. Where we've got the proper plates and so forth that allow you to do that. Now, of course, it's harder to do that on a retrofit construction, but on new construction, that's relatively easy to do if you know to allow for it. And then you can have everything at the same potential, which is a huge advantage if you can do it.
Now, Sojourner in the chat room is commenting, saying if you can float only one thing in the system, or he's asking, is it better, safer, to float the amplifier or some other components? Is there some sort of general rule about that?
In my experience, the real ground loop issues come with the subwoofer and with a set-top box. And the trouble with that is you kind of combat that in different ways. With the subwoofer, regarding Garth's comment earlier about wiring, I forget what the term that you use, kind of rejiggering extension cables in a code-compliant manner. But aside from that, the set-top box issue can be solved with line-level isolation transformers. Garth mentioned Jensen, things like that. I see a lot in the field, a lot of set-top boxes that have some odd ground issues in relation to a home theater system. And so when you wire in that coax line from the satellite dish or that cable line from the cable provider, that can cause ground loop hum as well.
Yeah, but as far as the amplifier goes, there's no hard, fast rule about, on average, will it be the power amplifier, will it be the powered receiver, will it be the powered subwoofer, will it be your server, your media streamer? Anything with a three-prong AC cord in any combination could be it. And with ground loops, it takes two to tango. There's going to be a source and there's going to be a load. Now, everybody always sees the problem manifest itself on the load, being either the screen, but via a projector or a flat screen, or hears it coming out of like the speaker, such as a powered subwoofer. So therefore, your eye and your ear and your brain immediately point to it and say, there's the problem. But the reality of it is that there's a source that's at a difference of voltage potential that's helping to create that. And if you can break one of the two of them, essentially you've solved the problem. Or if you can bring, all of their power cords back to, like one common bus to where everything's at the same potential, that problem goes away. Because again, it's like a tree trunk with branches. The branches could be a mile long, it could be an inch long. As long as they're coming back to one trunk, you're okay. The problem is when you have multiple trunks, and in most larger theaters, unfortunately, you do. So then it becomes a mathematical level of chance and probability about, is the voltage difference large enough to break into a full hum? Oftentimes you get lucky and it's not. Sometimes you're not so lucky.
Dreamscapes in the chat room is asking, do the ports on a surge protector have to coincide with the labeled equipment? For example, if it says TV, do I have to plug the TV into that port? I don't think so.
No, that's mostly marketing nonsense, and we do the same thing because everybody else does it, and you're sort of expected to do it.
Right.
Now, there are some exceptions to this. On our performance line, and also in the Panamex line, too, you'll have, on some of the larger component pieces, you'll have what are called high current outlets. And in our case, in the Furman, you'll even have power factor corrected, transient power factor corrected, actually, to be completely engineering proper. You have, in a situation like that, a special technology that's specifically for them, because power amplifiers will draw transient current when the volume gets up, and as having to draw a lot of current in such a way to where if you use the same kind of filters and the same kind of protectors that you would typically use for all the rest of your components, it would start to compress them, particularly larger amplifiers, which we have to use today. Because, and it's not about listening to 130 decibels and having blood rushing out of your ears or something like that. It's literally just trying to accurately and faithfully reproduce what's happening in your theater, like during an action sequence or a sporting sequence, or for that matter, a concert, and not even like a rock concert or a rave fest or something, or hip hop. It could very simply be like a classical, it could be a chamber ensemble, it could be a flamenco guitarist, it could be a grand piano. If you take a great condenser studio microphone and you look at, like a really fast peak meter, and you look at what you're trying to reproduce, it's extremely challenging. And the thing that's interesting is that there's always been, the best of the best, the elite, have always had great equipment through the decades. But on average, the average person, even the well-to-do average person, if you go back to the 1970s, most of this, software wasn't capable of much more than about 40 decibels of dynamic range. So, like a lot of this was just kind of inconsequential. But the problem today is our loudspeakers are essentially no more efficient than they were 35 years ago, and yet we're trying to produce 5 times the dynamic range, and 2 octaves of bass we routinely rolled off because, like our 4-inch speaker in the corner of your grandfather's console TV, not to mention, like a cheap FM radio, just couldn't handle it. No one would accept that now, but now you have a situation where instead of trying to determine, do we go for the 20 or the 30, like watt, amplifier or something like that for a home. Now we're looking at 200 watts, 300 watts. You can buy 10,000 watt switching amplifiers. And that's not overdoing it. That's just trying to make sure that you've got what you need in a big damp theater. So now you're pushing these amplifiers extremely, hard. The RMS current draw in most of these amplifiers might not really be, even for something that's 200 pounds, more than about 5 or 6 amps. But the transient current draw for less than 20 milliseconds could be as much as 60 amps. And it's fast enough that you're not going to take out the circuit breaker in your wall, but you're definitely going to have a problem if you plug into a strip that's not designed for that, or into the wrong outlet, to answer the other gentleman's question, that has a number of inductors, a number of relays, and other parts of the technology that raise the impedance, that raise the resistance. And with an amplifier, it's about lowering the resistance as much as possible. I mean, if you could get away with it in an ultimate scenario, instead of asking your electrician for a 20 amp dedicated line, you'd ask for an 80 amp dedicated line and say, and by the way, while you're at it, could you please take my theater and move it right next to the substation? That's essentially what you're after.
That's the ideal situation. Okay.
And that's actually what we try to do with transient power factor. It's essentially just like a very, very large capacitive buffer that essentially creates the same thing for about 20 milliseconds. I don't have to worry about more than that, because anything longer than that, you're getting into sustained RMS, and any decent power supply inside of any good amplifier will handle that. They handle that great. Even modest receivers handle that pretty well. It's the transients that are the problem. And that's why when you go down to a big box store and you look at the receiver that's the house brand, that's relatively inexpensive and perpetually on sale, you can pick it up with 3 fingers and you can kind of like cut the cord off and just like spin it around like a basketball, or like a ball on top of a seal's nose or something like that. Whereas if you're talking about something you'd really want to use, it comes in a wooden crate and takes 2 of you to lift. And they both say 200 watts, but they sure don't sound like the same 200 watts. Well, one of them's got a real power supply in it, and that's what you're hearing.
There are 3 key categories. You've got audio electronics, amplifiers. You've got video devices, and of course, set-top boxes and control systems that actually need a battery backup device. So naming of the outlets that's a convenience feature, whereas when you're actually wiring a system up, you have different criteria or different devices that actually need different power conditioners.
Exactly. Yeah, all by application.
All by application. A quick comment from SoCal Ray Jr., who says that he uses Panamax units because they offer brownout circuitry. They shut down equipment on low voltage, like on hot summer days here in L.A. Can you talk a minute about brownout protection? Blackout protection, obviously, is uninterruptible power supplies, a battery that keeps things running for a little while at least, so that you can shut them down gracefully. But what about brownouts?
Under voltage protection, over voltage protection, or brownouts, on the protection side, you really actually need a relay in the enclosure to shut off the power permanently until the power is restored 220 volts or thereabouts. So it's a different level of protection, and certain devices offer it, certain devices don't. But it has nothing to do with a joule rating, has nothing to do with battery backup. Whether or not you have the brownout or under voltage protection will actually be in the specifications of the device itself. And it should give you like a low voltage shut-off threshold. that kind of thing.
With Furman, it's a little bit different. I did a great deal of research into this because I was trying to understand what I had discovered in my laboratory for a number of years when I was designing the Furman home line, and reconcile that with, like what had been said. And the technologies in the Panamax and the Furman are somewhat different enough in terms of the surge and the overvoltage protection, and yet similar in other ways, to where what I ultimately came to realize is that there were two different methods of getting to the same place, which is obviously protecting the equipment and making sure that there's never a service call, never any downtime if you can possibly avoid it. But the one misnomer about this is that because of brownouts that people experience in the real world, there's an assumption that, and I've heard this and I've read this on chat lines and different places. Oh, brownouts, one of the worst things you can ever do. Low voltage, evil for your power supplies and for electronics. It'll destroy things. You've got to have under voltage protection. I've even heard under voltage protection is worse than over voltage. Well, if you stop and think about this for a minute, let's see. Let's put 3,000 volts into your power supply and see how it holds up. Now let's put 50 volts in your power supply that's meant for 120 and see what happens. I mean, it's pretty obvious that overvoltage is the bigger issue. And in fact, if you take a variac, which is just a large transformer with a big dial in front of it, and you kind of like poison or lower the voltage to 70 volts, 80 volts, 90 volts to power supplies and circuits that are meant for 120, ideally, RMS, right to the point where they turn off or they virtually go out of conduction. You can do this very fast or very slow all day long, and you will never, ever in a laboratory hurt that power supply ever. The problem, though, is that in the real world, there isn't, God isn't sitting there with a big variac. The problem there is that what's happening is that all of a sudden there's been some kind of like storm in your area, or what's also occurred is like someone's car or truck just like plowed into the power line. There's been a storm or something like that. You've just had a bunch of additions put into the neighborhood or something like that. The transformer that everyone's sharing is underrated and basically overtaxed for that area. The local utility really needs to do something about this, but they haven't quite gotten around to it yet because they're perpetually cheap. So you have a situation in situations like that where all of a sudden, when everybody gets on the grid, all of a sudden, the voltage just sagged down to 85 volts or something like that. My switching power supplies are right to the point of like turning off. This is really, really annoying me, and this isn't good. But that's actually not what's destroying your equipment. What's destroying your equipment is that the second that power pole is fixed, or that big appliance or that big factory turns off, what you have is essentially a fairly weak, high, resistance or high impedance power supply. It's like a spring, and it's very, very loose, and the voltage has been kind of compressed down. And the second that is released, boom! All of a sudden, you have a situation where you've got the mother of all peaks, and it comes really fast, and it's going to go right past, most power supplies and most, protection devices, and now you've got destroyed equipment. That can't happen with a Panamax because you've got overvoltage protection and overvoltage protection. With the Furman, you've got something that can handle any kind of possible fast peak that could come in and turn it into heat. They're both organic devices. I mean, they're not going to handle being put out in the middle of a field and having a light bulb hit them directly. I mean, they're going to carbonize. They're toast. But inside of a home or office, they've been both designed for 6,000 volts, 3,000 amps, which is the kind of UL 1449 and military A11 standard. What's significant about that is if you had about 3 or 4% more power than that from an electrical storm, even a direct hit, which we can handle if our devices are indoors. If it were more than that amount of power, 6,000 volts, 3,000 amps peak, what's going to occur is your glass meter outside of your building is going to shatter and explode like a bomb. Your circuit breaker panel is molten steel. All the wiring inside your house just went up in flames, as well as your home. At that point, the Panamax and the Furman are kind of irrelevant. Short of that, we're good.
Good points. Good points. Okay, we got a couple other questions, and there's another topic that I really want to make sure we get to. But before we do, I want to take a moment to thank our sponsor for this episode, which, of course, is Netflix. Now, Netflix, as most of you already know, provides thousands of TV episodes and movies that can be streamed directly to just about any consumer electronics device you might have in your home. TVs, Blu-ray players, game consoles, computers, of course, cell phones, smartphones, I should say, tablets, dedicated boxes like Roku and so on, other set-top boxes. As I said, just about any consumer electronics device these days has a Netflix app which lets you stream all of this content, all of these thousands of TV episodes and movies directly to those devices. You can even start on one device and finish on another. Say you start in your home theater and you say, you know what, I'm getting kind of sleepy. I think I'll go to bed, but I'd like to finish this program. So simply start it up again in your theater, in your bedroom, and finish watching what you want. The ultimate inconvenience, all for one low monthly fee. And in fact, for those few of you who might not have tried Netflix yet, there's a 30-day free trial. Just go to netflix.com/twit and start up that 30-day free trial and see what convenience can do for you. That's netflix.com/twit. And we thank Netflix very much for their support of Home Theater Geeks and the entire TWiT network. So, let's see. I've got a couple other questions here before we get to the performance issues, and I know there'll be a lot to say about that. TV's Egon has asked, I have several Panamax PowerMax 6s for over 12 years. Is there a finite lifespan on surge protection equipment? And Sojourner asks a similar question. Are surge protectors still good after they have had a surge applied to them? If not, how can you tell?
A properly designed protection device actually will not sacrifice itself in the event of a surge unless the device becomes overwhelmed to the point that it disconnects. So, for example, Panamax products, they will actually, if they become overwhelmed, and we're talking in excess of 6,000 volts or multiple surges, those devices would permanently disconnect themselves given a price point. We actually talked about earlier the brownout and the overvoltage protection a little bit. I mentioned the relay in the box, that sort of thing. Assuming you're at that price point, assuming you've got products that are kind of at that level, those products will not sacrifice themselves, again, unless they become overwhelmed with a tremendous kind of act of God surge. We're talking 20,000 amps, that sort of thing. But in terms of everyday use, in terms of you live in Florida, you live in Georgia, you live in the Carolinas, and or you live in a high lightning-prone area, then no, they will not over time wear down. Now, there are some lesser expensive products you may find inside of some mass market discounters that obviously are, $10, $20, $30. Those products I can't speak to. But in terms of the broad home theater market space, you're going to be okay. You're going to be fine.
Yeah. And by the way, in addition to that, and of course there's LED indicators on most of these things to let you know that your protection devices have taken a hit and they need to be replaced. Of course, in some instances, that's of little consequence if you've got it buried under, like a bunch of garbage underneath your desk, right, or behind the rack. So it is worth kind of like monitoring that every once in a while. But actually, in the case of the Panamax, it's protect or disconnect. So actually, it'll let you know that you come to that point, because if it's gone away, you've also basically lost your power. So it doesn't let you go through that scenario. Whereas the inexpensive stuff that's available in your mass market retailers and so forth, yeah, I mean, these people bring up a great point, because you can have lost essentially all of your protection, and those will just continue to be an outlet strip. You might have like a little LED warning light that's, depending on sensitivity, is on or not, depending on the quality of the unit. But then the problem is, if you can't see it, what good is that for you? So there is that. But one of the things that's also really important is that it's very easy when you talk about surge to think about the catastrophic hit and to think about lightning. And that's what everyone talks about. We do too. I mean, it's a great ad campaign. Like lightning storm coming to a theater near you, like Hide the Wife and Kids, that the locust and pestilence are not far behind. But the thing of it is that in reality, in Petaluma, California, where we're sitting here now, there's no chance of a lightning storm. It's not going to happen statistically. We've got a better chance of being swallowed up in a crevice of the earth from the next big earthquake. But we're not going to have a big lightning hit. The reason that you care about this is that with the kind of equipment you've got in this studio, and anyone has in their theater today, is the fact that you've got microprocessor chips. Nikola Tesla invented AC power. It's over a century old. And as brilliant as he was, and as far forward as he was for his time, and many, many, many decades beyond that, some of the things he invented were staggering. Brilliant man, but he couldn't have, like anybody at that time, envisioned where we would be in about a century. And the reality of it is that if you look at this, we were supposed to have valves about now, transistors at best. But that's not where we are. In the last 20 years, we've got the latest generation of microprocessing chips. And the problem with that is that a 3-volt arc over to the wrong, terminal across the little teeny outlet parts of those chips is enough to destroy them. And long before that, you can basically start to seriously impair and damage them, losing a lot of resolution, losing a lot of bandwidth and speed, and increases of distortion and increased lockups. And that's what I really care about, and that's where surge is so important today, because we have dozens of these, if not hundreds of these chips, throughout our theater, throughout our homes, throughout the things that the kind of people that are involved in this discipline really care about. And that's the problem. If you take a lot of these chips that can be the size of your thumbnail or your pinky nail, they're wafer thin. They're put together in clean rooms, with HEPA filters. You have a situation where these people have electrostatic discharge on their wrist, on their ankles. You can't take a lot of these chips and breathe on them without destroying their bandwidth. They have to be on the solder mask board first and placed in an electrostatic discharge, environment inside the component. And until that happens, those things are very, very vulnerable. They're sensitive as a toothache. If you were to take the valves, the vacuum tubes that Tesla thought we would still have, and try to make the average processor chip that we use today, you'd fill this entire room with circuitry floor to ceiling. You wouldn't have a quarter of the bandwidth. And I love vacuum tubes for certain audiophile applications. They make a great amplifier. They make a terrible processor. So if that's the case, but what no one ever considers about the digital revolution is you can't take a room full of circuitry, squeeze it down to something that's the size of my pinky nail, have 10,000 electrical junctions inside that silicon substrate, and not give something up. What we gave up was durability, and we gave it up by the truckload. And that's what I care about, because if you take two processors, identical, sequential serial numbers, as close to being identical as possible, and you keep one of them in the factory sealed carton and you put the other one in service, and let's be daring, let's plug it directly into the AC mains, no Panamex, no Furman, no surge protector from anybody, no UPS. In a place like Petaluma, California, 3 years later, it's probably still going to work. Statistically, that's the truth. I might have had to reboot it. I might have slapped it, on the chassis a couple of times. But the fact of the matter is, it's probably still going to work. But 3 years later, if I take its mate out of the sealed container and I put them side by side and compare the audio and video, I'm not going to need a spectrum analyzer or a scope. I'm not going to need a laboratory. The difference is stunning. They're not even close. But you didn't notice because everything was going away just a little bit at a time.
Very, very slowly.
Yep.
Well, that brings us to the other topic that I really wanted to cover today, which is the effect of AC power and AC power conditioning on performance, on AV performance, on audio and video performance. And I know that we've got some graphics here and an actual audio file to play people to demonstrate the profound effect, actually, that AC power conditioning has on audio performance. Tell us a little bit about the experiments that you've conducted in this regard.
Yeah, well, one of the things that I've done for years, I'm a trained musician and also, worked for years to try to improve audio and video performance where you had resolution, trying to, basically maintain that, and also make sure that through current compression and big amplifiers, you weren't, essentially doing that. In fact, I was trying to bolster the AC side of the power supply and allow you to have more dynamic range as you would by a lower impedance supply, as if you were, the analogy I gave earlier, being right by the substation. So how do you do these things? So various technology was come up with by both Furman and Panamex as well. I mean, both have very, very good linearized filtering and so forth. Every brand that does this has their own pitch, has their own filters, has their own ideas. And some of these are very straightforward. And then there are certain companies in the audiophile community where, well, okay, the parts are cryogenically frozen, and when the moon beads come in a particular direction, the crystalline structure of the wire, remembers it's coming from a more holistic place and feels better about itself. And the parts remember they were very cold once, and that's why it works better.
That's right.
Well, yeah, I'm not necessarily, we're into real science here, but the thing of it is that there is something to be said for the fact that if you're trying to reproduce today with some digital files, as much as 120 dB of dynamic range, certainly 100, and you have an unweighted noise floor of somewhere around negative 70, like your power supply is going to try to get rid of, depending on its quality, anywhere from 70, 80, 90, 95% of that signal. But the fact of the matter is, through current bursts and through ground, a certain amount of that noise is going to get through. Well, if we're talking about the home theater of the 1990s and it's a VHS tape with 40 decibels of dynamic range, and your noise floor is 30 decibels below the quietest signal, who cares, other than a broadcaster? But the problem's going to be that today, if you're trying to reproduce 1080, if you're trying to reproduce Blu-ray, if you're trying to produce 24-bit audio.
Or 4K.
Yeah, exactly, Marshall. So now all of a sudden, whoa, now all of a sudden we've got a situation where our noise floor is higher than our quietest signal. Now we've got a problem because we've got a masking effect. We just did this. Or we just threw a bunch of gauze and dirt over the screen. So we want to squeegee that away. We want to we want to take the blanket away from the speakers. But to do that, we've got to get rid of the noise. To do that, we're going to have to do this over the widest bandwidth of frequencies possible, and we're going to have to do it as evenly or linearly as we possibly can. These are some of the technologies we've worked on very hard, and as well as things for amplifiers where we can lower the resistance and give them a current reservoir, isolation transformers, balanced power to where we can lower the common mode noise even further. In the same way that noise reduction has worked in a studio or a live microphone for years, where you can have a Shure SM58 and you can have a mile of mic cable going over the lighting ballast and everything like that, and no one typically hears any hum. Why? Because there is a balanced transformer right at the output of that microphone. You can do the same thing for power, except that instead of having millivolts coming out of that piece, now you're having to deal with 120 volts. So instead of a transformer that's the size of the end of my thumb, now you've got a transformer that's 70 pounds and takes two of us to lift. But it's the same principle.
You know, Scott, one of the interesting things that he mentioned was 120 dB, the Red Book, CD, actually 118, format. If we're talking about reference performance,
I thought Red Book CD was 96.
It is. But if we're talking about, for 24 bits when it goes up.
24-bit, then we're up at 120 or 118.
24-bit, yeah.
Exactly.
So if we're talking about that level of performance, a real reference, then you're talking about a different level of power conditioner. If you're talking about a home theater system, multi-channel audio, different people consume media in different ways. And if we're watching a movie and the lights aren't controlled, we don't have the display calibrated, maybe it rained in as good as it could be, then we're talking about a different system. So it really depends on what level that you're talking about.
Absolutely. Yeah, you don't want to overplay this because it's a situation where if it's distributed audio or something like that, I'm not going to sit there and tell them, our reference at over $3,000, every man, woman, and child needs one. Absolutely.
In every room.
Yeah, exactly. That's ridiculous. I mean, it's in the same way that the Pirelli high-performance tires or the Yokohamas that you would put on a Ferrari don't need to go on your, your Honda Fit. I mean, it's a bad match.
Right. So you actually did some experiments, and I want to make sure we show this. There was an audio track, and I think we have the first of 3 graphics that we can show here that lists all the parameters of this particular experiment in which you played an audio track. Let's see if we can make it come up. We're working on that. There it is.
There we go.
I can't read it in the small little window I'm looking at, but it's tell us what the track was and what the parameters were.
Well, I mean, it could have been any track, but I just wanted a track that I knew was going to have a lot of resolution. And so what I did is it's wonderful to be able to do an A/B comparison, but it requires a really good audio system, or if I'm going to do it with video, a really good video loop and under really controlled circumstances. And oftentimes I just don't have that ability. So I wanted, and also just for all the engineers that said I've heard a lot of things. So power supply should fix all these problems, or maybe power is bad out in the country, but I've got a really expensive environment here. We don't have those problems. So I wanted some real science to just dispel that myth once and for all, because there's no power anywhere in the world that's good enough for the level of resolution we're trying to deal with today. So I wanted to do a simple differential file. So I went to a studio, took a good CD player or a universal player, took its digital out, put it through a D to A converter. Then I put that output into an A to D converter, upscaled it to 24-bit 96K, and then put the first 8 seconds into the into the studio's Macintosh and just created a 24-bit WAV file. And then everything was plugged directly into the wall. All the studio equipment, everything. Second time, we plugged into our reference technology from Furman. Discrete symmetrical power. We had like linearized filtering, transient power factor, and so forth. And then everything we did the exact same thing. Everything's plugged in that. Now, this particular software I used is not mine. It comes from it's freeware that comes from a place in Ann Arbor, Michigan called Audio Diff Maker. And I took the 2 WAV files and you import it into that, and it automatically lines up the beginning and the end down to just like the last microsecond and make sure that the medium volume's the same. And then you hit extract, and it creates a third composite WAV file of those 2. But before it does that, it takes the second file and it reverses polarity. So what you have in that third resulting file is the difference. And if these power supplies in these upper end equipment are perfect, as some of these manufacturers claim to me frequently, then the difference will be 0. You'll hear absolutely and see nothing. If the power is perfect at that recording studio, as they told me it was, the difference will be 0. Well, I knew better than that. I've heard and seen the difference too many times. But even I kind of imagine, I'd only heard and seen things get better. I had more dimension, more black level, more depth of field for video, more harmonics, more spatial cues in audio. I had never heard the difference alone, which was fascinating to me. I kind of thought, well, this is if I look at like the fundamentals being the compressed media that anything can reproduce, that would be most of the musical content. So if we're looking at the signal that's going to be 30, that's going to be the last, 30 decibels or so of noise, I thought that's going to be harmonics, that's going to be transient, some spatial cues. It'll sound like space noises. I probably won't be able to recognize that this was 3 flamenco guitarists originally. The melody will be long gone, but the fact that there's any kind of like random noise there at all is proof positive that this is signal that's being lost forever, never to be reproduced. Millions of dollars of processors, you'll never get it back once it's gone. And it starts here. So that was the thing. So what you will hear on this little 8-second file is essentially, it's been amplified, but essentially this is the difference file. All this information that you'll hear would have been gone forever if not for the AC power management technology.
So let's see if we can hear it.
I'm familiar with that recording, but through 5 doors away, I know what that recording is, and I can hear that pretty easily. I was rather appalled and shocked, even myself being in the industry, to know, oh my God, we're losing that much.
Now, just to make sure everybody understands, what we just heard is the audio information that was lost when all of the equipment that you used was plugged into the wall of a professional recording studio, as compared to the audio information that was retained when everything was plugged into Furman power conditioning. And this is going to be true of other power conditioners as well. Perhaps
yes.
not as good as yours, but we won't go there.
No, actually, we did tests with others, and what I can tell you is that they're almost all of them, except for maybe very inexpensive strips from like a big box store, all improved. All had some of this effect. They all improved the signal.
Scott, there was actually an iTunes match comparison, kind of a shootout a few weeks ago, comparing the iTunes remastered for iTunes, kind of new format that Apple was trying to push. And they used a really similar test. It was basically a test, take the source file, second copy, invert and compare the two, and what you see is what you heard, or the difference of the 2 files.
Right. Yeah. And
so this is the difference. What we heard is the difference between the 2 files. One processed without any power conditioning and one processed with power conditioning. Exactly. This is quite astonishing to me that there could be that much difference in the audio chain based upon whether or not you were conditioning the AC power. How do you explain such a big difference?
Because of the masking effect. Again, it's very simple. If you're taking a massive dynamic range of 90 to 100 or more decibels, and your unweighted noise at certain frequencies is as much as 10, 20, 30, 40 decibels higher than your quietest signal, it's going to do one of 2 things. It's either going to distort the signal or it's going to mask the signal. And that's corrupted or lost information. And once that information is lost, it's lost forever. That's the problem, and that's what we're trying to correct at this point. And it's only going to
and so conditioning the power actually lowers the noise floor
considerably. No, you put this kind of technology into a recording studio. The thing I've done for years, particularly with the older analog consoles that are still being used in a lot of top flight studios, as well as the digital ones. You just like take the mic pre, put it into the bus. Put every fader maxed to where if you hit the 1K slate tone, you'd go deaf. You know, it's about 80 decibels too hot right now. But it's just so that you can hear the self noise of the studio and the equipment. And you have everything plugged directly in the wall. Then you take this technology and you plug everything into it, and you can hear and go down to,
Go down to nothing.
Go down to nothing. Yeah, and the thing is that you have to understand, and they understand this in broadcast and studio, all of that and you're tracking that, and it's not just that you're worried about, well, because people could sit there and very legitimately say, well, I've never heard or going through my audio tracks. No, you don't. It's an insidious level of noise. What you don't hear is everything that you're missing as a result of all that noise, and not seen as a result of that noise, and that's what we care about.
And that's Fred Flintstone's asking the question, does it apply to video as well, equally?
Yes. Now, again, this has to do with your level of dynamic range. So, for instance, if you're talking about an animation, that's compressed media. Even if it's, like 4K, that makes no difference. And besides, who knows what a big blotch of red digitally derived really looks like in the real world anyways. That's easy to reproduce. It's why when you go into, sorry, Best Buy, you go to a place like that, and everybody's like running an automation with the fluorescent lights shining on everything. Nothing's calibrated, because in an environment like that, who's going to know? And it's an easy cheat. But if you've got a situation where you've got a really high def loop or something like that that's being played, that's pretty unprocessed and it's got a lot of integrity to it, and you've got it on a really good projector or a good plasma, oh, you bet, because then you've got a lot of dynamic range, you've got a lot of bandwidth, and that's going to be vulnerable to noise.
Now, I'm curious why you took a CD and upscaled it essentially to 9624 rather than taking a true 9624 original source file. And I'd be curious to know what would happen in that situation. I guess it would be similar.
It'd be similar, and it'd be even a little bit better, because we would have had more resolution. I wanted to start with something very simple and very mundane that I've been carrying around with me for years, just to prove the point that you don't have to have millions of dollars worth of equipment. You don't have to have a storage medium that only the elite have at this point. That this would apply to what we've been doing for a long time now. Now, but this is not to say this applies to everything. And it's an important point to make, because if I'm talking about an MP3 player, the difference wouldn't be as dramatic, because I have
that was my next question. Yeah, that was my next question.
I have no resolution in a situation like that. An MP3 is 1% of a Redbook CD.
Right.
Which makes it a tenth of 1% of vinyl.
Marshall, did you want to add something there?
Well, the interesting thing is, in video, we talk about things like black level. We talk about things like frequency, sharpness. As you increase in frequency, you get more resolution out of the actual image itself. And when you render that and you appreciate that in the home theater environment, and you actually look at that and you kind of analyze it a little bit, it matters a lot, the playback material. It matters a lot who the viewer is. It matters a lot what your source material is. And so the appreciable differences between these key technologies, and Garth's demo was tremendous, but it's easier to notice in a two-channel environment. It's easier to notice when you take away a few of the distractions. Or said differently, if you have a calibrated environment, if you've got a properly tuned room, or a room that you're at least using some sort of acoustic calibration, whether it be proprietary inside the audio-video receiver or some sort of outboard processor, it matters a lot if you're calibrating by input, by source component, and by display, all your different video settings. So, as you kind of increase that overall performance system in terms of level, you'll see more appreciable differences with power conditioning. You can't say, for example, you take a nice, Sharp, Elite, or Sony's new 4K flat panel and throw a $40 power conditioner onto that product, and it makes a night and day difference. Right. You'll see a bigger difference with a greater quality component, because the overall ceiling of kind of where you can get to is better.
Sure.
I wanted to also just point out that you did this experiment again with shall I call it a cheapy power strip, just some sort of minimal surge protector. And what was the difference there?
Zero. No different than the wall.
No difference. No
different than the wall.
Yeah. Yeah. So, like the people that, like sometimes, you see all over the internet and everything like that. Oh, all these, like people that want to sit there, it's all zeros and ones. HDMI cable, at $100 versus this one for $3. They're virtually the same. Well, in certain applications, depending on the signal and depending on, because again, just throwing money at something doesn't mean it's well engineered and well designed. It could very well be that it's no better. It might be worse. On the other hand, it's not to say that all these cables are the same. I mean, I've seen legitimate and measured legitimate differences in HDMI cables that are several hundreds of dollars. But is that something that the average consumer needs? Of course not. But no. if you've got the kind of environment, you've got the kind of system where you're trying to push everything right to its technological edge. It's the same as anything else. If you want a Ferrari, if you want a Porsche, if you want a BMW, you want that level of experience, you got to pay for it.
Caffeine-free Dave asks, what about whole home power conditioning as opposed to keeping the conditioning as close to as possible to the equipment itself?
Well, for whole home power conditioning, your light bulbs will love it. Nice for inexpensive appliances as well. For anything that you really care about the performance of, no, because the problem is that even if it was good enough to get rid of all of the noise coming from the rest of the world, and very few of those things are, the technology on most of them are fairly weak. But even if that wasn't the case, the big problem that I have, and the reason that I won't design one that way, I certainly could, if it could be done properly, it solves a lot of problems, even if it has to be very big and expensive. The problem with that, it makes a lot of sense at first blush. The problem is that a lot of the microsurges that are generated inside a home or an office are generated internally, which are going to go right past the secondary of that whole house device, rendering it useless. The second problem is that the noise. If I've got something, at my main entrance that's getting rid of the noise from the outside world, even if it's perfect, that gets rid of, okay, maybe 60–70% of the noise or something like that. But I've still got all of the noise coming from, the digital processors inside of my Blu-ray, getting and modulating my preamplifier, because they're all directly connected to the same bus bar of my multi-strip or power conditioner. And my big amplifiers are modulating my scaler and my streamer. I don't want that to happen. I want them to each have their own set of filters or circuits, protection, and isolation, as much isolation as possible. It can never be 100%, I realize, but the closer you get to that, the better off you're going to be, and it's noticeable.
Devices in your home theater system itself actually generate AC noise.
Of course.
Your set-top box, your PS3, your streamer, all those sources have their own power supplies, operating at different voltages, different frequencies, and they all actually generate noise. So by actually putting something
and that goes back down the power cord and into the main line, it sort of goes backwards?
Absolutely.
Backwashes. The FCC has, and also the compliance people have regulations about how much of that you can allow. This is why you see those little round,
RF
sort of like cylinder, like RF, like ferrite shields.
Chokes.
It chokes.
Ferrite chokes.
Ferrite chokes at the end of a lot of these cords, because it's the poor man's cheap way of trying to just squeeze past the FCC regulations. But what's festering under that is horrible. And, I'm 49 years old. I started in this industry at age 15. I was already at that point not only a technician at a 2-channel salon, but I was also apprenticing for 2 broadcast engineers. And I can tell you, I was spoiled rotten, had access to some of the best technological equipment in some of these labs. And I can tell you, at a frequency as low as 3,000 cycles per second or 3,000 hertz, I wouldn't have seen on the AC line a millivolt of noise in those days. Today, if I'm near a server room, I can measure 3 volts. That's what's happened. Our AC line is destroyed where performance is concerned, and it's not going to get better.
And different products tackle that differently. Some products use isolation transformers and a balance configuration. That's Furman's discrete symmetrical balance power.
Right.
Panamax actually uses an LCR network, which is basically a capacitor and an inductor network to filter the power. So not all products are created equal. And of course, when you spend some more money on those products, you'll get real noise reduction technology out to octaves of bandwidth. Right. So, different pieces for different problems.
Right. And not to mention the fact, different levels of a performance, because you want to put the right thing with the right application. There's no point. We like to say, like about 5 to 10% of your hardware budget goes towards power management. You don't throw $2,000 worth of power management on a $500 system. That's ridiculous. There's no place for it. It makes no sense.
Right. Well, we're running a little over time, but there's one last question I really want to try and squeeze in here, which is from Web 1650. Both companies, Panamax and Furman, have power conditioners in similar price ranges. I mean, I guess, Panamax goes up to some place, Furman comes down to some place, they kind of meet in the middle someplace. Comparing tech specs and features is difficult for a regular consumer. What should consumers look for in terms of features that are better for amplifiers versus displays and so on?
Well, I think as time moves on, there's going to be less overlap where that's concerned. That comes from the fact that when we were originally purchased, we still had individual people representing the two lines and certain retail spots that were kind of like one or the other, even though we were together as one. We knew that in terms of our company, but like our partners didn't necessarily, and so we had to kind of like work through that. But essentially what it tends to be is, with some exception, at retail up to about 700 or 800 at retail, more times than not, it would be Panamax. After that, it would probably be Furman, but there are exceptions in both of those cases. And so that's not even a hard, fast rule either. And as far as
understood,
as far as technological specs go, the technological specs in our equipment are the same as technological specs in amplifiers and every video processor there ever was. Take them, find a match, burn them. Use your eye, use your ear.
Well, I certainly do say that about tech specs in many cases in terms of TVs and audio equipment and so on. Okay, well, I'm going to let that be the last word then, because we are running a little late, and the next show is queuing up and ready to go. Okay. I want to thank you so much, both of you, Garth Powell from Furman and Marshall Currier from Panamax, both of you in the studio today and providing us with an incredible and daunting amount of information, which I'm sure people will need to listen to more than once. Thanks so much.
Thank you.
Thanks, Kay.
So you can get to their websites. You can get to Furman at furmansound.com and to Panamax at panamax.com and read all about the products that both companies offer in their now interrelated way. And you can reach me, of course, by emailing at scott@twit.tv. You can also read my answers to listener and reader questions at hometheaterhifi.com. And you can follow me on Twitter at htgeekscott. Next week, my guest geek is scheduled to be Tom Sumner, who's a VP at Yamaha. And we're going to be talking about Yamaha as a company because it is celebrating its 125th anniversary. They make all kinds of stuff, including lots of home theater products, which we will be focusing on. So I do hope you will join me for that, because I think it's going to be fascinating. Until then, geek out.